Please briefly introduce yourselves and summarize your industry education, professional background, and current role at Contech.
Hi, I'm Glen Payton. I'm Stormwater Consultant for Contech in the territories of Tennessee, Alabama, and Western Georgia. My background is I've been in the stormwater management business for about 15 years. And my educational background is a BS in chemical engineering from Washington University in St. Louis and an MBA from Lehigh University in Pennsylvania.
My name is Kim Rich. I'm currently the engineering manager of the East Stormwater section. And my educational background is I'm a biological systems engineer, graduated from Virginia Tech, specializing in water resources. And I'm also currently a PE registered in the state of Maryland.
How does Contech fit within the infrastructure industry?
You know, Contech is a provider of manufactured goods. So we reach all over the civil and engineering industry. So infrastructure as a whole, and, specifically with Stormwater Group, that's where we work. Most everything we do besides our Filterra product is underground. So we're right there with stormwater conveyance. We're there to help with DOT jobs and things like that. We know with the infrastructure bill being passed, I think it's a good opportunity for stormwater and Contech specifically to kind of stand out. I think a lot of people think of water infrastructure as wastewater, but really a large part of that is stormwater. So yeah, I think Contech fits right in there, being the provider of manufactured treatment devices and detention products for stormwater industry.
What can you tell us about the project in Atlanta, and what were some of the unique challenges faced?
So the project was a very large facility that required significant stormwater management in general, specifically attenuation of large storms to prevent significant washout downstream of the facility. And they were also requiring some treatment capabilities. And so Contech was able to provide us a unique, innovative system that met the interests and the needs of the owner from the very outset. We gave them 3 or 4 different opportunities or possibilities to solve that attenuation problem, and they chose not the least expensive and certainly not the most expensive, but they chose the one that best met their needs for a good price point. So something that just met their needs, but also went beyond that and gave them some security and peace of mind with a little bit more expensive product than the very least expensive option.
So I would add a unique challenge with this particular project, and adding on to what Glenn said with the type of product they provided being polymer coated CMP. The life cycle of the product was very important to the customer. They wanted something that would last for years and years. So that was very unique when we work with a lot of projects, wanting the owner to be involved for 100 years or so is not something we are commonly seeing. So that was definitely unique.
Yeah, specifically, good point, Kim. The polymer coated the polymer coated corrugated steel product gave them a 100-year service life effectively with the environmental conditions of that site, as opposed to a traditional aluminized type 2 corrugated metal pipe system that we oftentimes offer would have given them about 75-year service life. So they felt more comfortable and gave them better peace of mind to pay a little bit more for this kind of intermediate type of price product, so that they were able to get a little bit more for their dollar and meet the needs of their clients, which is effectively providing a facility that's going to be there for, as Kim said, 100 years effectively.
How is the engineering of data centers, specifically, different from most other large projects?
Yeah, so Contech works with varying size projects all the time. With large projects, those could be in a bunch of different categories as far as we see. Could be residential, could be commercial, shopping. So I would say the biggest difference with data centers and other large warehouse distribution projects is the speed. They can really build those and install them really, really quickly, which then with us providing a large quantity of in this case, metal pipe, really speeds up our production time required to provide it by the time that they need to install it. In a typical residential job, that might be the same dollar value. We might provide 10 or 20 smaller detention systems that have a staggered, due date for installation or something, so we can work with that. But really having such a large quantity delivered and installed at one time is typical of data center and warehouse distribution jobs.
And Todd, we were able to bring in some unique capabilities that really sped up the installation process, specifically using our mobile mill. Effectively, the job was so large because it basically had a very large impervious area, a large data center. And the unique aspects of the project itself allowed for a very deep installation. The system could be very large. We went beyond our normal pipe diameter of typical 144-inch diameter. We went up to 162-inch diameter, and that basically required us, or allowed us, to use the mobile mill, where we brought the plant to the facility and allowed the manufacture of the pipe right there on job site, which helped not only in excessive freight costs being saved, because we didn't have to ship empty pipe from one of our fixed plants in the country. We were able to just ship coil to the job site and then create the pipe right there on site. But as important, we were able to stage and have the contractor stage and install the pipe as we produced it. So the installation time frame was significantly reduced.
Since you brought it up, please tell me a little bit more about the pipe manufacturing process on site. What might some of the difficulties be with that process?
The process, the production method is identical to our fixed plants. It's just that we are able to take a very small component, just effectively the pipe manufacturing plant itself. And we have 2 of these units throughout the country, and they're heavily used throughout the country. And we deliver that manufacturing facility to the plant, and effectively it's the same process in making the pipe. It's where you're basically you're bending corrugated metal, taking steel rolls, flat steel rolls, and bending them and corrugating them into spirally into a pipe format, if you will, form. And you're basically crimping the pipe to seal along that spiral. So you create effectively a soil type pipe with that system. This particular pipe was polymer coated steel. So we had fairly thick polymer coating on both sides of the steel. And it was also 10 gauge steel. So it was pretty thick material. And it's not that easy to bend and form into corrugations and spiral form. But our plant, again, is equipped to do that, both the mobile plants as well as the fixed plants. So in terms of actual production, it's not that much more difficult than what we experienced in our fixed plant. It's just that we put that plant on job site.
I would add that a big benefit to using our mobile production vehicle is the cost savings on freight. And also the time in manufacturing is a little bit less, because since we don't have to worry about freight and don't have to worry about the size of the truck that we're putting the pipe on, we're able to manufacture those sticks or lengths of pipe to be much longer than we would typically. So it does require a lot of communication and work with the contractor so that they're able to store all of that on site, because we can basically roll the pipe almost as fast or faster than they can lay the pipe and install it in the trench. But yeah, we can make much longer pieces, so it's a big benefit.
What is void saver technology, and how does it work with stone?
So void saver technology is a patented process that Contech owns. It's effectively a means by which the objective is to use stone void as supplemental storage. That stone is the bedding stone that surrounds the pipe itself. So the pipe conveys or carries 80–90% of the total volume of the system. But there is bedding stone around the pipe. That stone has roughly 40% void volume. and that void volume can be used for storage. And what that translates to is that use of that stone void storage allows the system to be smaller in overall footprint, and that saves in basically total installed costs in terms of excavation, stone material, pipe material, and installation cost itself. So what Void Saver technology does is it effectively reserves the use of that stone voids for only the largest storms, typically say the 25-year storm and above. The theory is that those larger storms have already, by the time the 25-year storm or larger gets to the facility, that detention system, most of this sediment and other pollutants have been already flushed through the system, so that additional storm volume is relatively clean. So that storm volume can go into the stone voids and be used. And it's a very fairly simple mechanism by which we use check valves and effectively an opening at the top of the pipe that allows the water to go as the storm increases in size. The water goes from the pipe into the stone voids only for the largest storms, and then the check valves within the pipe itself allow that the water within the stone voids to exit back into the pipe, and then therefore go back leave the facility effectively when the storm subsides. So it's really a kind of a slick system that just allows the largest storms to be used for that stone void storage. And what that does is it protects that stone void capacity, because if the smaller storms, which have a lot of sediment, were to access that stone void volume, those smaller storms would introduce sediment into that stone voids, and eventually over time those stone voids would get filled with sediment, and that capacity would be lost forever because you just cannot remove that. So the owners were very interested in that feature because it helped really ensure the capacity of the system over time. And that was something else that they were willing to they valued. The value of that system was well in excess of the incremental cost that we had to incur in installing that system in that feature in this system.
In making sure that we utilize the void overflow that's placed in our CMP properly for that 25-year storm, there was a lot of back and forth and a lot of communication required with the engineer of record, because in doing so and placing that overflow vent and making sure we have enough check valves, we wanted to make sure that we were still meeting the pre versus post construction flow requirements on site. So it required a lot of routing. We went from the 1 year all the way up to the 100-year storm, and we were able to successfully not exceed the post-construction flows by working with the engineer really closely.
And that was an excellent example of the capabilities that Contech brings, not only in our products, which have, in this case, unique features such as patented void saver technology, but also the capabilities of our engineering group to run the HydroCAD routing, do the calculations, and yet integrate that and work with our engineering clients to make sure that the proper features are delivered to the owner. So we do have those capabilities. We're pretty broad in our capabilities in terms of personnel as well as products in the stormwater management arena.
How much did Contech work with the other engineers, contractors, and owners? And how were those relationships?
So that's kind of how much is kind of a relative term. I would think that we work very closely on most projects. There are situations where projects are small and we kind of get the engineer what they need and move on. But Contech, as I mentioned before, Contech has a wide range of personnel in various positions that support effectively, eventually, the owner's interests in getting a functional facility in the ground. Such as on this project. So the personnel that are involved are like myself, stormwater consultant, working with the engineers, and we're backed up and fully complemented by the engineering design group represented by Kim Rich here. We also have a sales engineer that works with the contractor, GC, and in times the owner on a particular project. And again, this particular project was a good example of that, in that our sales engineer, Victoria Hiring, worked closely with the subcontractor and at times with the GC to make sure that our product was being produced in the sequence and the timing that they needed. We worked very closely with them on job site to make sure that what was being produced was going to be able to be put in very quickly, and it was also, again, sequenced in the right sequence, so that it would support our production, would support the installation schedule. In addition, we have other individuals like a field operations team that supports the installation and post-construction inspection. And so we had a couple of post-construction inspection processes where our field operations group came in and actually measured deflection in this particular project, because 162-inch pipe under roughly 20 to 30 foot of cover can experience some deflection, even if it's 10 gauge. But we ensured to the owner that the deflection amounts, the amount of pipe squished down, if you will, was within limits, within proper limits. And we confirmed that with our field operations survey done inside the pipe itself. While this project was a little more heavily weighted towards close working on the engineering level, subcontractor level, GC, and owner level, we often employ those teams on every project, really. And it's just in a various amount of attention is needed, and we customize our team for the needs of the project.
And I would add on this project, what made it unique and different even from other large projects, definitely the timeline that Glenn mentioned, for us to make sure we were in step with the contractor, getting them the pipe when they needed it. We did have weekly meetings with the owner, and then when the contractor was selected, they would join the meetings as well, and our team as well. And how long did that go on for, Glenn? Like 3 months, maybe?
So yeah, the project started in roughly early summer, late spring, early summer of 2020. We established weekly, and I think it was all Microsoft Teams meetings, because the owners were in another part of the country. And those meetings went on for about 6 months. The project was, if I get it right, I think we started really installation about 9 months after we started the initial contact with the owner, somewhere in that range. And the whole project was finished well within a year of that first contact, when the owner reached out effectively to me on their needs. So it was very fast track, especially for a project of this size. This project involved over 500,000 cubic feet of detention storage. And for a project of this size, it went extremely fast, and we had very close contact with the engineering, all elements of the parties involved. All the stakeholders in this project were deeply in communication and vice versa with Contech, and that really ultimately was a key component of the success of the project.
Yep. I would second that. Without that weekly communication, one blip in the production schedule or something could have easily snowballed, but that didn't happen because we were so in step with the whole team.
What did you learn from this project? And what could you pass along to other engineers working on similar projects?
Yeah, I would say communication is the most important thing. And also really honing in and understanding what the client and the customer needs. We had a lot of competition, other providers, with great options as well. But in the end, we won this job because we were able to specifically satisfy our customers' needs for this unique project.
I would completely agree with Kim. I think the communication levels were very frequent and comprehensive across all disciplines, and that it doesn't happen on all projects because it doesn't need to. But this project was big enough and complex enough, and the owner was deep, very strong, heavily involved in the project, and so there was a lot of owner-specific questions that we wouldn't necessarily have to deal with because owners typically aren't as closely involved. So I think having our team engaged and able to answer their questions, which were relevant, but answer their questions in a timely manner really engendered confidence in the owner for them to look closely at our proposal and in the early stages and give us the green light very quickly. Again, from the time we started in the first Contech in the late spring, the owner effectively pulled the trigger in about 2 months, and it was on a big project with a very tight timeline on their schedule, and they were taking a big risk to go with us or anybody else because they had such a tight timeline. And I think that's the communication was really key to moving things along quickly. And I think that is a good lesson for us all to learn as a company.
How about some advice for those other engineers?
I would say understand your client's needs as closely as possible. There was some assumptions that we made early on that were not realized in the project, and really discussions with the owner to really probe what their reasons for their particular preferences, not just hearing what they need, but why they need it is key to understanding how to solve the problem. And I would just underline that for any Contech engineer that we have working on a project for our clients, and certainly any design engineer that we work with as a client, they need to understand that from their owners as much as possible. And that allows you to solve the problem and only solve the problem, and not go beyond that, because going beyond that oftentimes means unnecessary expense.
What were some unexpected major surprises on this project, either good or bad?
I think nothing that was unexpected, but I think the expected challenge that we had was definitely the cover, as Glenn mentioned, and the slope. That was something we weren't really able to fully analyze until the design was done. And since the design was moving almost as fast as the production was, that was something really challenging to fully analyze. Like weren't really sure how many rows of the detention system there was going to be until, a couple months before we started production. So really analyzing the differential loading that was on the pipe, because one end of the pipe, there ended up being 5 rows. They were about, I think, 600 or so feet long each. But like on the north row, for instance, there was about 30 feet of cover. And on the southmost row, there was maybe only 10 feet of cover. So that differential loading was definitely a challenge that we analyzed and added structural reinforcing to the fittings as needed. So it was an expected issue, but unexpected in that it came much later in the project than we probably initially intended.
Yeah, I would second that. I think that was the biggest and most pressing issue. And the owner was deeply concerned about all the issues of this project, including, the mechanical or structural integrity. And we engaged even went all the way up to our chief engineer to weigh in on any additional structural modifications we might make to what would be an otherwise standard kind of product. And as Kim mentioned, the slope, effectively we kind of had to go beyond our norm in many cases on this project. And one was the slope. It was steeper than we would normally work with on these particular type systems, but there was no options otherwise to really reduce the slope. We just had to work with it. So our engineering team, all the way up to our chief engineer, really developed the solution, and we implemented it, and it came out fine.